Hi there. I just wanted to summarize Module 1 and kind of give my 2 cents and also talk about some of the questions and responses that came up. If I look to the side, it's just because I'm looking at some notes that I've made. So first, tackling the question of mathematics content for teaching. So a few great responses, many great responses. But one thing I want to talk about first is just an example about why content for teaching is important. So here's a standard table of values that we might pose to a grade 9 applied student. Might give them this table of values and ask them what the equation might be. And a very common response that a student will give us is this: y equals x plus 4. Now, knowing mathematics tells me that this equation is wrong. And in fact, if I'm assigning marks for the rate of change, the rate of change is wrong. If I'm assigning marks for the initial value is wrong. So just mathematics tells me that there's nothing right about this equation. But mathematics content for teaching requires that I understand the fact that in grade 8, many growing patterns that we talk about and the students talk about only require students to see things additively. So the fact that this pattern grows by 4 is very important in grade 8 and grade 7. In grade 9, we would like to see the students develop multiplicative thinking. So for example, 1 times 4 plus 2 is 6. 2 times 4 plus 2 is 10. 3 times 4 plus 2 is 14. So that fact that it's times 4 is important. This comes from the student's understanding that it goes up by 4 every time, which is a very rudimentary understanding of growing patterns. But because I have that content for teaching mathematics, I can give the student valuable feedback. Kristen, I think, said it very well right at the beginning. And she said that it gives us the ability to quickly reflect on students' work. And Brittany then added later that it gives us the ability to react to students' work. And I think that that's the key to sound content for teaching mathematics. Kristen also had the question of how much of this should we share with students? So how much of our content of mathematics should we share with the students? And in my opinion, as much as possible, but without being overwhelming. So I want them to get a full grasp of the curriculum, and I want them to get a full grasp of everything that I know in the background of the curriculum, but I don't want it to be overwhelming. So that means that it's on a student by student basis. Some students I'll push thinking further, other students I'll be happy with where they are. Daniel brought up the point of cognitive bias and the fact that everybody's going to see it a different way. So this content for teaching poses kind of a problem, because can we really anticipate all the different ways that people are going to see it? And we as teachers have our own biases. And I think the answer to that is yes, that's true. But we as teachers have to get over that hurdle, and we have to be able to see the work in as many ways as possible. Some people pitched a lot of really interesting solutions. Laura had the question of should elementary teachers all be specialists in math? And whether I agree or not doesn't matter, but there is push for both. And the idea is that if we don't have a specialist, then the student spends more time with the teacher. If we do have a specialist, the student spends less time with that teacher, but they're more of an expert in their knowledge. So the idea is, how do we train more non-specialists to understand all that's required in content for teaching math? And so Remedja brought up the problem that not a lot of people like taking math AQs and things like that. And there's a big push to kind of get people to realize that that's important. And so I hope that you all learn a lot from this course, and that you continue to try to develop your content knowledge And I'll share some resources as we go through this course that'll hopefully help you with that. Rebecca posed a really good question asking, how do we grasp all the pitfalls that our students are going to have when we haven't taught a course yet? And my answer to that is you have to do the math, and do the math in as many ways as possible before you pose it to your students. There's a really good resource for that. It's called the 5 Practices for Orchestrating Mathematical Discussion, and it's by Peggy Smith. It's a wonderful resource, and it kind of shows you how you might go through solving a problem, and then how you might use your solutions to guide what's going to happen in the classroom so that students get the most out of it. And the final point is about question number 2 about teacher inquiry. And before I get into it, I just want to point out that some people had some issues distinguishing between teacher inquiry and teaching inquiry-based lessons. Inquiry-based lessons are very important, but teacher inquiry is the process that we as teachers go through to check whether what we're doing with our students is beneficial. So that means that we try things, we share things with others, and we see how our students are progressing. If you're still having trouble struggling with that, the capacity building series reading called Collaborative Teacher Inquiry is fantastic. It's one of the resources in the module. Other than that, many responses on that topic were great. And I hope you'll continue to involve yourself in teacher inquiry as you get going on your teaching careers. Okay, we'll see you all next module.